Hello Precalculus students, this is your Conics review, and in the first section we are going to identify what type of conic section each equation represents. So if you look through them, the easiest thing to find is the parabola first, because the parabola has only one squared term. So looking through them, it looks like number 7 is a parabola. I'll put P for parabola. And it looks like that might be the only one. Next thing I'm going to look for is a circle. For a circle, the coefficient of the x squared and the y squared should be the same number, and they should both be positive. So if I look at number 1, I have 1x squared and 1y squared, so that would be a circle. And then keep looking through them. Looks like number 3, it's also the same number, so that's also a circle. And this one looks like they are almost the same, except that I have one that's positive and I have one that's negative, so that would make this one actually a hyperbola. So let's go through and find the rest of the hyperbolas. You're looking for an x squared term or a y squared term that's positive, and then the other one is negative. So positive, 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 negative. Positive, 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 negative. Okay, so then if the coefficients of x squared and y squared are both positive, but they're different numbers, that would create an ellipse. So this is ellipse, this is ellipse. All right, let's go down. Alright, first of all, you should be able to identify that this whole first row, these are all parabolas. And if the x squared term is, if the x term is the squared one, then your parabola will be opening up or down. So this one and this one. And if the y term is squared, then your parabola would be opening left or right. So that would be this one and this one. So in number 9, you have an x squared, and everything is positive, so it's going to open up. So number 9 is A. And this one is the same, except that you have a negative, which means it's going to open down. So that would be this one, C. All right, these are the left-right parabolas. The positive one is going to open to the right, so that will be D. And the negative one is going to open to the left, so that will be H. Okay, down here we have some ellipses and some hyperbolas. You can tell the difference because the ellipses have the plus and the hyperbolas have the minus. So I have 2 ellipses here. This one is going 1 in the x direction and it's going 2 in the y direction. So let's look at the ellipses. Going 1 in the x direction, it doesn't work. This one, going 1 in the x direction works, and going 2 in the y direction, that works as well. So this is G. This one goes 2 in the x direction and 1 in the y direction. So from the center, you go 2 in the x direction, and you go 1 in the y direction, so this one works, F. All right, looking at the 2 hyperbolas, this one starts with an x squared. The x squared is the positive, so I like to think that's going to cut through the x-axis. So I'm looking at my 2 hyperbolas, and it cuts through the x-axis. So this one is going to be E. And then for 16, it's the y squared that's positive. And let's take a look. So this one will cut through the y-axis, so this one will be B. Okay, we're going to graph. So when you start graphing, the first thing you want to do is decide what shape you have. So I see that they're being added, and they have denominators, different denominators. So this one's going to be an ellipse. And this one has no denominators, so this one's going to be a circle. Let's start by finding the center of your ellipse. Okay. So the center is going to have an x-coordinate, that's the opposite of this number, so -2. and there's nothing with the y, so that's going to be 0. So center is negative 2, 0. Okay, I'm going to change my denominators to squares, so 25 is the same as 5 squared, and 36 is the same as 6 squared. So in the x direction, left and right, I'm going to go 5. So from negative 2 I go back 5, and I go forward 5. In the y direction, which is up and down, I'm going to go 6. Okay, and then sketch your ellipse, do your best to make it rounded. And if you need to graph the foci, you're going to use c squared equals a squared minus b squared. Okay, so remember that a is the larger of these two numbers, so that would be 6. So I have 6 squared, which is 36. B is the smaller of these two numbers, which is 5, so 5 squared is 25. So c squared equals 11. And although that algebraically this has two answers, positive root 11 and negative root 11, since we're expressing a distance, we're going to use the positive answer. So c is going to equal the square root of 11, which is approximately 3.3. So remember that the foci are going to be on the major axis, the longer axis, and from the center you're going to go up 3.3, and you're going to go down 3.3. All right, next we're going to do a circle. In the circle we have a center. The center is going to be the opposite of this and the opposite of this. So negative 4, nope, positive 4, sorry, and negative 3. All right, so 4, negative 3. The radius of the circle is the square root of this number because this is always r squared. So that means the radius is going to be 2. So from the center you go 2 in each direction, up, down, left, right, and do your best to draw a circle. You can use a compass if you want to get it exact, like that. All right, let's move on to the next page. Okay, in this one we're going to graph a hyperbola. And graphing a hyperbola starts a lot like graphing an ellipse. You want to find the center. Be careful with the hyperbola because sometimes the y comes first and the x coordinate of the center is going to be the opposite of the number that's with the x. So negative 2 and 1. All right, so you're going to graph that point, and then we're going to express the denominators as squares. So this is the same as 4 squared, and this is the same as 2 squared. So we're going to go to negative 2, 1. And in the x direction, left and right, we're going to go 2. Y direction, up and down, we're going to go 4. And instead of graphing the ellipse here, because it's a hyperbola, we graph a dashed box. Okay, and then you want to draw the diagonals of the box, and you want to extend them so that they create the asymptotes for your hyperbola. Let's see if I can do that here. Okay, and so of course the asymptotes are going to go in both directions forever, and then you're going to sketch in your hyperbola. So you need to know if your branches are up and down or left and right. And the way you find that is you look at the term that's squared that's positive. So that's the first one, because this minus makes the second term negative. So the one that's positive is the y. So my branches are going to be up and down. And notice you have to hit this point on the rectangle, that's the vertex. Okay, if you need the foci for the hyperbola, the equation is going to be c squared equals a squared plus b squared instead of minus. And so that would be 16 plus 4, so c squared is going to equal 20, and c is going to equal the square root of 20, which is 2 root 5, and we'll put that in a calculator and get an approximation. So c is about 4.5, so from the center you go 4.5. Alright, the last ones all seem to be parabolas, and so you need to consider the equation of the parabola. This one has a y term that's squared, so you have y minus k squared equals 4p times x minus h. So you're going to find the vertex with the h comma k. Okay, so the opposite of this number and the opposite of this number. So that would be -2, -5. Alright, and then you want to find your p-value. So you take this number that's outside the linear term, and you're going to do 4p, which is here, equals 4, and divide both sides by 4 to get p equals 1. You're going to use that p to find the location of the focus and the directrix. So now remember that the focus, let's change color, the focus is going to be h plus p comma k. So it's going to have the same y value as the vertex, but it's going to have a different x value. So in this case, I have -2 plus 1, so I get -1, and then k is the same, -5. For the directrix, it's going to be x equals h minus p. So in this case, the h is -2 minus 1, so I get x equals -3. Okay, so let's graph. I'm going to start by graphing the vertex at -2, -5. And then I'm going to graph the directrix at x equals -3. And I'm going to graph the focus at -1, -5. Okay, so you probably already figured out that this is going to open to the right because of the location of the directrix and the location of the focus, but you can also tell it's going to open to the right because it's the y term that's squared and everything is positive. To find another set of points on your parabola, remember that your points on your parabola have to be the same distance from the focus and from the directrix. So an easy way to find a set of points that's the same distance is take that distance of p and double it, which is going to be 2 here. So p had a distance of 1, and I double it, I get a distance of 2. And I'm going to go 2 straight up from the focus. So now notice I have a point that is 2 away from the focus and 2 away from the directrix. So that point is on my parabola. And because of symmetry, I know that there's another point down here. And now I can use these 3 points to sketch my parabola. You may also want your axis of symmetry here. So the axis of symmetry is going to cut your parabola in half, like this. All right, and my axis of symmetry is y equals -5. Okay, we have another parabola here, but this one is going to open up or down because my x term is the one that's squared. So I'm going to use a slightly different equation. This time I'm using 4p times y minus k equals x minus h squared. Okay, and then I'm going to start by finding my vertex. My vertex is going to be opposite of this number, -1, opposite of this number, +1. Okay, let's see. Stick with blue for the moment, good. So I have 4p's here, and that equals this one, -4. So if I divide by 4, I get p equals -1. So now for the focus, it's going to be h, comma, k plus p. So my h stays the same at -1, and my y value here is going to be 1 plus -1, which is 0. For the directrix, I'm going to use y equals k minus p. Alright, so that will be 1 minus -1, which becomes plus, so that's y equals 2. Alright, so let's see what we can graph here. We're going to graph the vertex at -1, 1. And then I'm going to graph the focus at -1, 0, and the directrix at y equals 2. Okay, I can graph another set of points that is on the parabola because I take this distance p. Now I know my p is officially -1, but it's a distance of 1, and I double that to be 2. So I'm going to take the distance of 2, and I'm going to go across from my focus. I'm going to go 2. And because of symmetry, I'll go 2 the other way as well. And then take a look at the points I graphed. This point is 2 away from the focus and 2 away from the directrix, so I know that it is on the graph of the parabola. And I'm going to sketch the parabola using those points. And let's see if this shape matches what I expected. It's the x squared the x is squared, so it's going to open up or down, and because of the negative here, it actually ends up opening down. The last thing you're going to want is your axis of symmetry, which cuts your parabola in half. So I'm going to draw it right here. It's a line of symmetry for the parabola, and my axis of symmetry is going to be x equals -1. Alright, for this last one, I think it looks like I'm going to need to complete the square in order to get this in standard form. My square term is the y one, so I'm going to look at the linear term for the y. That's this 2 right here, and this is the number that I need to divide by 2. Let me change my color back. So I'm going to take that 2 and I'm going to divide it by 2, and I'm going to square it, and I get 1. So 1 is the number that's going to complete the square for y squared plus 2y. So I take that y squared plus 2y, and I'm going to add 1 to it. I'm going to move the x terms to the other side and the 13 as well. So I have negative 6x. If I add that to both sides, I get 6x on the right. If I subtract 13 from both sides, I get negative 13 on the right. And because I added 1 to the left, that's this one right here, I have to add 1 to the right as well. So now I have a trinomial that is the square of a binomial. So the square root of y squared is y, the square root of 1 is 1, so this is the square of y plus 1. Over here, combining like terms, I get 6x minus 12. And I need to factor the coefficient of the x out. So that would be 6 times x minus 2. And I still have y plus 1 squared. So my vertex is going to be positive 2, negative 1. And let's see, let's find my p-value. So I know 4p is equal to this number, 6. And if I divide by 4, I get p equals 1.5. So for my focus, I need to add 1.5 to my x value here. So 2 plus 1.5 is 3.5. And keep my negative 1 here. For my directrix, it's going to be x equals, and let's see, it's going to be 2 minus 1.5, so it's going to be 0.5. Alright, so let's do some graphing. I'm going to graph the vertex at 2, negative 1. And I'm going to graph the focus at 3.5, negative 1. And I'm going to graph the directrix at x equals 0.5, so here. Okay. To find 2 more points that are on my parabola, I need to take my p-value and double it. That would be 3. And from the focus, I'm going to go up 3, and I'm going to go down 3. And now these 2 points are 3 away from the focus, and they are 3 away from the directrix. And so they're on my parabola. Okay. My axis of symmetry is right here. And that's going to be y equals negative 1. Okay. Let's write the equation of the conic. So you can average the endpoints to find the location of the center, or you can just eyeball it and just check your answer. I can see that I'm 4 away from each end, so I found it. So the center is going to be negative 3, 0. And then the radius is 1, 2, 3, 4. So the radius equals 4. So you're going to use those in the equation of your circle. So it would be x minus negative 3, so I get x plus 3, plus y minus 0 squared is just y squared, and that's going to equal r squared, so that's going to equal 16. Okay, here we have the ellipse. You can find your center. And so that center is going to tell you that it's going to be x. Oh, I should write the center. The center is at negative 2, positive 1. So it would be x minus negative 2, so x plus 2 squared. Come back for the denominator, plus y minus 1 squared, and the denominator here in the x direction, I'm going 2, so that's going to be 2 squared, which is 4. In the y direction, I'm going 4, so 4 squared is 16, and then the ellipse is going to be set equal to 1. Alright, the last one here is a parabola, and our parabola is opening to the left. So what we're going to do is start with the equation y minus k squared equals 4p times x minus h. Now I can see the vertex is right here, so the vertex is at negative 3, 3, and that gives me the h and it gives me the k. But what I need to find is I need to find the p-value. So in order to find the p-value, I need another point on the parabola that I'm going to use to substitute for x and y, and then I can find my p-value from that. So I can see that there's a point right here, and I'm going to use that point negative 5, 4. So I'm going to substitute negative 5 for the x and 4 for the y. Alright, so substituting in, I have 4 minus 3 squared equals 4p times negative 5 minus negative 3, so that's plus 3. So notice I got h and k from here, that's the h and the k. X and y came from here. Alright, so let's simplify a little bit. I get 1 squared is 1, and I have 4p times negative 2. Alright, so I'm not going to bother multiplying the 4 times the negative 2, because in my equation I actually need 4p, so I can just solve for 4p. So I'm going to divide by negative 2, and I get 4p equals negative 1/2. So negative 1/2 is the number I'm going to put right here. Alright, so up here I have y, and it's supposed to be y minus k, so the k value is 3, squared equals, instead of 4p, I put in negative 1/2, that's what I found. And then I have x, and it should be minus negative 3, so that becomes plus 3. Okay, 26 and 27 says to solve on a separate page. There's not really room to solve them here, so you should pull out a piece of paper for that. And remember, you can also use that same piece of paper to define and illustrate your words. This is a part of your review packet, so you are expected to write a definition and draw a picture for each one. Alright, so let's go to the next page and do 26 and 27. Alright, we can do both of these problems by substitution. I'm going to take the x minus 1 and I'm going to substitute it for the y. So I'm going to rewrite the equation. Instead of starting with y equals, I start with negative x plus 1 equals, and then all of this. Now I can see it's a quadratic equation. To solve a quadratic, you need to make one side 0. So I'm going to add the x to move it to the right and subtract the 1. So now this side is 0. X squared plus 2x minus 3. So I'm going to factor this. And I need numbers that multiply to negative 3 and add to 2. Those numbers are 3 and minus 1. So if you set both factors equal to 0, you get x equals negative 3 and x equals positive 1. So the solutions to the systems are the points where the parabola, this one, crosses the line. So for those points, I need x values and y values. So I'm going to substitute these back into one of the equations to find the y values. Now, you can substitute them into either one, but the linear equation is much more simple. So I'm going to use that one. Y equals negative x plus 1. And then I'm going to plug that x value that I found, negative 3, into the equation. Same thing for this one. Y equals negative x plus 1. And then I'm going to plug my x value of 1 in there. So this one gives me 4. And then I have a point when x is negative 3, y is 4. And this one gives me 0. So I have the point 1, 0. So this system has two solutions. All right, in 27, our system is a line and a circle. So we are going to substitute again. This time I'm going to put 3x minus 30 in for the y. So I'm going to write x squared plus something squared equals 100. And I put that 3x minus 30 here. Now when you square a binomial, remember that you cannot just square each term. You have to multiply it by itself. So I have x squared plus 3x minus 30 times 3x minus 30 equals 100. X squared plus 3x times 3x is 9x squared. 3x times negative 30 is negative 90x, and I have another negative 90x here, so that gives me negative 180x, and negative 30 times negative 30 is positive 900. So to solve the quadratic, I need to combine like terms, and I need to make one side 0. So I have x squared plus 9x squared, I have 10x squared. Minus 180x, and I'm going to subtract the 100 to move it over here, so I have plus 800 equals 0. So to simplify this problem, we can divide both sides by 10. Oops. And I get x squared minus 18x plus 80 equals 0. So again, you want to factor and find numbers that multiply to negative 80, multiply to positive 80 and add to negative 18. So a negative 8 times a negative 10 gives you positive 80 and adds to negative 18. So I get x equals 8 and x equals 10. So to find the y coordinates, you want to put those numbers back into one of these equations. The line is going to be the easiest one. So y equals 3 times the x minus 30. Y equals 3 times the x minus 30. Okay, and this is 8, and this is 10. So this one gives me 24 minus 30. It gives me negative 6. And this one gives me 30 minus 30, so it gives me 0. So my points are 8, negative 6, and 10, 0. Okay, so if you have finished your review problems, remember that your next task is to find these words. You can probably find most of them in your notes. You can look up the ones you don't have and draw a picture that illustrates each one.